Hello, we are discussing about GATE 2003 ECE paper. 12 1 ohm resistances are used as edges to form a cube. Find the resistance between two diagonally opposite corners of the cube. Okay. The equivalent resistance between two diagonally opposite corners of the cube when the cube is made up of 1 ohm resistances. Okay. All edges are having 1 ohm resistance. So first we will draw a cube. So this is the cube. Okay, and for this cube, this is one diagonal element, this is one more diagonal, both are going to be opposite of each other. So where you are going to find the equivalent impedance between these two nodes. Okay, we are going to find the equivalent impedance or equivalent resistance between two diagonally opposite corners. This is corner 1 and it is corner 2, for example. Okay, so the other corners we can write it as 3, 4 and which are not important for this one, 5, 6, 7, 8. We are only interested in these corners. So here we are going to find the impedance or equivalent between these two terms. For that one, simply what you have to do is you apply a test voltage source V. Okay, and because of that one you will get some current, that is I, which is flowing through this cube and it is coming back to this one. Okay, and R equivalent can be written as V divided by I. V divided by I, and every branch is going to be having equivalent resistance. The resistance value is 1 ohm. Okay, so at this node, this is current I is dividing into 3 branches. Okay, and each current, if you are observing, each current, it is dividing into 3 branches and each branch again dividing into 2 paths. Okay, each branch is again dividing into 2 paths. So definitely we can say that one, all are going through the equal impedances. All are going through equal impedances because the current I is dividing into 3 branches and those 3 branches are again dividing into 2 more branches. And each branch is having same resistance, so definitely we can say this current is I by 3, 1 by 3rd of I, as it is equally divided. Okay, I in 3 parts, you can write it as I by 3. So this is I by 3 and I by 3 is dividing into 2 parts, which is nothing but half of I by 3. So this is I by 6. Okay, and it is I by 6, I by 6. Okay, and this current which is also I by 6, and this is I by 6 and this is I by 6. As you are looking at, this current is coming in this way, this is, both the currents are incoming, so that the outgoing current is I by 6 plus I by 6, which means I by 3. Okay, now we will write the expression for the KVL. We are going to write KVL now. That KVL, okay, is going to be from this branch through this 1 3 branch and 3 4 branch and 4 2 branch, and we are coming back to this V. So write KVL for this one. This KVL includes branch 1, branch 2 and branch 3. Each branch having resistance of R. Let us assume all are equal resistances and R value is given 1 ohm. That 1 ohm we will substitute it at last. So you can write the KVL. KVL V is equal to first branch. This has R, so I by 3 into R. So that is I by 3 into R plus second branch. Second branch is I by 6 is the current. So I by 6 is the current and the resistance of the branch is R. Third branch is I by 3. So current is I by 3 into resistance is R. So this is what KVL. So from this one, V is equal to R by 3 plus R by 6 plus R by 3 into I. And R equivalent is V by I. So V by I is equal to, you can write it as 2R by 6. 2R by 6 plus R by 6 plus 2R by 6. So which is equal to 5R by 6 ohms. So if R is equal to 1 ohm, then R equivalent for this one is 5 by 6 ohms. Okay. So if R is 10 ohms, then it is 5 by 6 into 10. If R is 100 ohms, 5 by 6 into 100. So whatever the value of R, the equation for this one is equivalent resistance between two diagonally opposite corners of the cube is 5R by 6. So the right option for this question is A. A is the right option.